Hello friends, in this video let us talk about Maxwell's equations and Helmholtz equation. So this is the introductory class. So in this video I am going to discuss more about Maxwell's equation as well as Helmholtz equation. So this entire EMTL or field theory you can classify into static field as well as a time varying field. So in the case of static field you need to talk about electrostatic and you need to talk about magnetostatic. And in the case of time varying field you need to talk about electromagnetic field, where electric field as well as magnetic fields are perpendicular to each other. Hello friends, this is Arun Kumar. I welcome you to my channel Craving Gyan. If you're visiting first time to my channel, make sure you're going to subscribe to my channel and click on the bell icon to get instant notification whenever I upload a new video. Now first let us talk about Maxwell's equation. So how Maxwell's equation is very much helpful in order to analyze or in order to study these EMTL subjects, and later we can talk about Helmholtz equation. So in this electrostatic, this electric field which is varying with respect to space is a function of charge. But if I am talking about magnetostatic, magnetic field which is varying with respect to space is a function of current. Similarly, if I am talking about electromagnetic wave, you will be getting E cross H, which is equals to, or which is a function of power which is varying with respect to space as well as time, and it is also a function of di by dt. It is also a function of di by dt, nothing but change in current. So this one you are going to call it as acceleration charge. This one you are going to call it as an acceleration charge. Now what do you mean by E, which is a function of Q? Nothing but electric field is a function of charge. So here in this case you will be considering source is a static charge. Here source is a static charge. But if I am talking about magnetostatic, here if you are talking about magnetostatic, charge at constant motion. Charge at constant motion. Whenever the charge is at constant motion or whenever the current is at constant motion, so you will be calling that one as a DC current or DC charge. Now let us talk about Maxwell's equation. The first form of Maxwell's equation is curl E, which is equals to minus dou B divided by dou T. So this is Faraday's law. So this is Faraday's law. Now this one, if I am relating with respect to static field, what I will be getting is curl E equals to 0. Now what is the significance of curl E becoming 0? All those things I will be discussing later part of my video. The second form of Maxwell's equation is curl H equals to J. So this is Ampere's law. Now if I am talking about modified Ampere's law, I will be getting curl H equals to J plus dou D divided by dou T. So this is modified Ampere's law, where J is the conduction current that is given by sigma E and dou D divided by dou T is the displacement current. Now if I am talking about static field, it is curl H equals to J. Curl H equals to J. Now the third form of Maxwell's equation is del dot D, which is equals to rho V. So here also we will be getting del dot D. What is D? Which is equals to epsilon E. So I will be getting del dot D, which is equals to rho V, or I can write it as epsilon times of del dot E, which is equals to rho V. Now the fourth form of Maxwell's equation, that is del dot B, which is equals to 0. What is B? It is a mu H. Mu times of del dot H, which is equals to 0. So this is all about the Maxwell's equation. Now if I am talking about static Maxwell's equation, that is electrostatic and magnetostatic, you need to talk. And in the case of time varying field, you need to talk about electromagnetic field. That is, these are all four forms of Maxwell's equation. This is very important. You have to remember. Now what is the significance of writing, or what do you mean by curl H equals to 0 or mu times of del dot H, which is equals to 0? If I am writing mu times of del dot H, which is equals to 0, what do you mean by del dot? Nothing but a radial motion. So if it is becoming 0, nothing but it will not be having any radial motion. So in the case of magnetostatic, you will not be having radial motion, but it is rotational. Because curl means a rotational motion, dot means or divergence means it is a radial motion. So these things you should know. Similarly, I got del dot d which is equals to rho v, nothing but I am having a radial motion. I am having a radial motion. And if I am writing curl E equals to 0, nothing but it will not be having rotational motion. It will not be having rotational motion. If you are preparing for UGC NET exam, these type of MCQs are very important. In the case of electric field, you will be having radial motion and you will not be having rotational motion. But in the case of magnetic field, you will be having rotational motion and you will not be having radial motion. So MCQs are very important. They may ask questions based on this. And I told it is irrotational, but here it is conservative. These things are very important. Here it is conservative, but here it is non-conservative. Rotational but not conservative. In the case of electrostatic, it is conservative but not rotational. So these things are very important. You should remember. Now let me revise Maxwell's equation. We are having 4 forms of Maxwell's equation. The first one is curl E equals to minus dou B divided by dou T. And second form of Maxwell's equation is curl H equals to J plus dou D by dou T. This is also called as modified Ampere's law. And if I am talking about Gauss law, del dot D which is equals to rho V as well as del dot B which is equals to 0. So these things are very important. Now let me compare static Maxwell's equation with time varying Maxwell's equation. So the first form is curl E equals to minus dou B divided by dou T. What is the significance of writing curl E equals to minus dou B divided by dou T? And in the case of static field, it is curl E equals to 0 because the differentiation term is getting 0 because differentiation of a constant is always 0. So what does it signifies means it signifies that electric field is irrotational. Electric field is irrotational. And if I am talking in terms of integral form, it is closed line integral E dot dl which is equals to 0. What this implies means E tangential 1 which is equals to E tangential 2. So I can tell electric field is conservative. Electric field is conservative but irrotational. But it is irrotational. Now, if I am talking about second form of Maxwell's equation, that is curl H equals to J plus dou D divided by dou T. So in the case of static, it is curl H equals to J. What do you mean by curl H becoming J? In the form of integral, what can I write means closed line integral H dot dl which is equals to the current that is enclosed in the path. The current that is enclosed in the path. So I can write this one as H tangential 1 minus H tangential 2 which is equals to J cross AN. So this is very important. So from this, how can I define means magnetic field is rotational. Magnetic field is rotational but not conservative. Magnetic field is rotational but not conservative. So these things are very important. If you are preparing for UGC NET exams or engineering service examinations, you have to remember these things. Which is rotational, which is conservative, which is not rotational. So these things are very important. Take a snapshot of it and even take a snapshot of this one also. So this is very important. Now, if I am talking about Gauss law, so we are having 2 forms of Gauss law, that is del dot D which is equals to rho V and you will be having del dot B which is 0. So in order to explain del dot D equals to rho V, what do you mean by del dot D means it is a radial flow of electric flux. Del dot D means it is a radial flow of electric flux. Now what do you mean by rho V? So rho V means isolated electric source or electric charge, you can tell. Electric source or charge do exist. Now, in order to understand del dot D equals to rho V, so let me make use of a positive charge. So in this positive charge, all the electric field lines will be moving outwards. It will be moving outwards. So outward movement will be there, but inward movement is not there. So I'll be getting dN1 which is not equals to 0, where dN1 indicates outflow movement, dN2 indicates inflow moment. So I'll be getting dN2 which is equals to 0. Next, if I am talking about a negative charge, all the electric field lines will be into it, So what I'll be getting is dN1 which is an outward movement will be 0 over here, but dN2 will not be equals to 0. So what I'll be getting is, based on this, what I can derive means dN1 is not equals to dN2. dN1 is not equals to dN2. So what I'll be getting is del dot D which is equals to plus or minus rho V. So we got del dot D which is equals to plus or minus rho V, or I can write dN1 minus dN2 which is equals to rho V. So this plus or minus sign will be taken care by dN1 and dN2. So based on this, what I can tell is isolated electric charge exists. Isolated electric charge will exist. Nothing but you will be getting isolated positive charge, or you can find negative charge. So it is isolated electric charge do exist. Now if I am talking about del dot B which is equals to 0. So what do you mean by del dot B which is equals to 0 means, that is Bn1 minus Bn2 which is equals to 0. So I need to talk about normal components. So what does it tells means, isolated magnetic charge or isolated magnetic pole will not exist. So isolated magnetic pole or isolated magnetic charge will not exist. Nothing but you will not be getting a north pole, or you will not be getting only a south pole. So this is very, very important. Say suppose you consider any bar magnet of your choice. So in the bar magnet you will be having north pole and south pole. Say suppose if I am dividing this bar magnet, or if I am breaking the bar magnet, what I will be getting is this one to be a north pole and south pole. Again I will be getting north pole and south pole. So isolated magnetic pole will not exist. And if I am talking about the north pole, magnetic flux lines will be away from north pole and it will get into south pole. Inside the bar magnet, magnetic flux lines will pass through it. So based on this, what I will be getting is this one as Bn1 and this one to be Bn2. So net flux should be equals to 0. That is what I have written, that is Bn1 minus Bn2 should be equals to 0. So this Bn1 I can call it as B normal component. So isolated magnetic charge do not exist, isolated electric charge do exist. So this is one more thing what you have to remember. Now if I am talking about Helmholtz equation, say suppose how you are going to represent wave. So wave representation or the wave equation will be del square E which is equals to gamma square E, where gamma is the propagation constant. How you can write this equation as? So this equation you can write it as del square minus gamma square of E which is equals to 0. Now what do you mean by this del square? Del square, if I am talking about xyz coordinate, what I will be getting is dou square divided by dou x square plus dou square divided by dou y square plus dou square divided by dou z square minus gamma square of E which is equals to 0. Now if I am talking about del, it is dou by dou x plus dou by dou y plus dou by dou z. If I am talking about del square, it is dou square divided by dou x square. So these things are very, very important, you should go through. Now in the case of waveguide, so this is the wave equation. In the case of waveguide, this is the wave equation. But in the case of transmission line, what are you going to replace is, you are going to replace this electric field with voltage. So what I will be getting is del square minus gamma square of, instead of E I am going to write it as V which is equals to 0. But in the case of antenna, so in the case of antenna, how this Helmholtz equation will be modified means, it is del square minus gamma square of A which is equals to mu times of J. So this is very important. Again I am going to repeat, entire your EMTL will stand upon Maxwell's equation as well as Helmholtz equation. In the case of Helmholtz equation, especially if you are dealing with waveguides, del square minus gamma square of E, which is equals to 0. In the case of transmission line, it is del square minus gamma square of V, which is equals to 0. But in the case of antenna, you need to talk about area of cross section, that is del square minus gamma square of A, which is equals to mu times of J. Next, these things are very important. So what do you mean by divergence? Means in the case of divergence you need to talk about radial motion, but in the case of curl you need to talk about rotational motion. What do you mean by radial motion, rotational motion? All those things let us discuss in next lecture. Now what does Stokes theorem says? It is going to talk about the closed line integral to open surface integral. So that's the relation it is going to derive. In the case of divergence theorem, it is going to talk about closed surface to open volume. Stokes theorem, closed line to open surface. Divergence theorem, closed surface to open volume. What is continuity equation? It is talking about the conservation of charge. You watch any EMTL lectures of your choice, first thing is they will be talking about static things. But if you are preparing exclusively for GATE exams, this electrostatic and magnetostatic, as of now they have removed. You need to concentrate more on electromagnetic field. You go through UGC NET papers or you go through set papers, maximum weightage is given for electromagnetic. Since you are very much thorough, or in your 12th and in your engineering you have talked about or you have studied more on electrostatic and magnetostatic, let me not focus more on electrostatic and magnetostatic. Straight away let us get into electromagnetic field and we shall discuss with respect to waveguides, transmission line and antennas. So if I am talking about Helmholtz equation, let us derive Helmholtz equation from Maxwell's equation. We know that from Faraday's law, that is curl E equals to minus dou B divided by dou T. Now if I am talking about second forms of Maxwell's law, that is curl H equals to J plus dou D divided by dou T. Right? Now what do you mean by B? It is mu times of H. Let me take curl on both sides. So what I will be getting is curl of curl E, which is equals to curl of dou B divided by dou T. But what do you mean by B? It is mu times of H, where mu is a constant value. Mu is a constant one. If I am assuming mu as a constant one, what I will be getting is minus mu times of dou divided by dou T of curl H. I will be getting minus mu times of dou by dou T of curl H. Now this is curl of curl E. What is curl of curl E? It is del of del dot E minus del square E. So this is a conversion you should know, which is equals to minus mu times of dou by dou T of what is curl H. So let me call this one as equation 1. So from 1 what I will be getting is curl H equals to J plus dou D divided by dou T. Next, let me take del of del dot E. It will be equals to 0. So what I will be getting is minus del square E, which is equals to minus mu times of dou by dou T of J plus what is the D? D equals to epsilon times of E. So it is J plus epsilon times of dou E divided by dou T. Dou E divided by dou T. So this minus term and minus term I can cancel. So what I will be getting is del square E, which is equals to mu, I am going to write as it is, d by dt or dou by dou T, you can write it as j omega into what is J? J equals to sigma E, nothing but conduction current, plus dou by dou T, I am going to write it as j omega into epsilon, I am going to write as it is into E, nothing but electric field I am going to write as it is. So what I will be getting is, so this entire term I am going to call it as gamma. What do you mean by propagation constant? That is gamma, which is equals to, we can define it as under root of j omega mu into sigma plus j omega epsilon. So how you can replace this one? So you can replace by del square E, which is equals to gamma square E. So this is Helmholtz equation. So this is Helmholtz equation. So that's how we are going to derive this Helmholtz equation from Maxwell's equation. So this is very important. Again, I am going to repeat, entire your EMTL will stand upon Maxwell's equation and Helmholtz equation. So let us derive the conclusion based on the Helmholtz equation what we got. So we got del dot D, which is equals to rho V, that is dn1 minus dn2, which is equals to rho V. Plus or minus will be taken care by dn1 and dn2. Now if I am talking about curl E equals to minus dou B divided by dou T. This indicates that E tangential 1 minus E tangential 2, which is equals to 0. That is E tangential 1, which is equals to E tangential 2. Now what do you mean by tangential component? What do you mean by normal component? All those things let us discuss in next lectures. This is one form of Gauss law, and the second form of Gauss law is del dot B, which is equals to 0. This tells that Bn1 minus Bn2, which is equals to 0. Rotation, not conservative. And another form of Maxwell's equation is curl H equals to J plus dou D divided by dou T. That tells that H tangential 1 minus H tangential 2, which is equals to J cross propagating vector, that is AN. So this entire things are very important. This entire things are very important. Please go through it. Main thing is you have to focus on this equation. And one more thing is, for waveguides, what is the equation you are going to make use? For transmission line, what is the equation? For antennas, what is the equation you should know? So this table is very important. Please take a snapshot of it. Now, if I am talking about time varying field, static, non-homogeneous and homogeneous medium. In the case of time varying field, we know that Maxwell's equation, that is curl H equals to J plus dou D divided by dou T. In the case of static, it is curl H equals to J. And second form of Maxwell's equation is curl E equals to minus dou B divided by dou T. And here, in the case of static, it is curl E equals to 0. Curl E equals to 0. And second form is del dot D, which is equals to rho V, and del dot B, which is equals to 0. So this is Gauss law. And here, in the case of static, it is del dot D equals to rho V, del dot B equals to 0. In the case of non-homogeneous medium, it is a del of epsilon times of E, which is equals to rho V. In the case of homogeneous medium, dielectric medium is constant throughout. So I can take epsilon as constant. So I'll be getting del dot E, which is equals to rho V divided by epsilon. So this is very important. So this is very important. In the case of non-homogeneous medium, it is a del dot of mu H, which is equals to 0. Here, in the case of homogeneous medium, mu is a constant. So we'll be getting mu times of del dot H, which is equals to 0, or del dot H, which will be equals to 0. So this is one more thing what you have to remember. Basic thing is, if they are asking non-homogeneous medium, these equations are valid. In the case of homogeneous medium, these equations are valid. So this is very important. And the last topic let us discuss with respect to Poisson's equation and Laplace equation. So we know that del dot D, which is equals to rho V, where D equals to epsilon times of E. So what I will be getting is del dot of epsilon times of E, which is equals to rho V. So let me consider an homogeneous medium. What I will be getting is rho V. So I will be getting del dot E, which is equals to rho V divided by epsilon. Del dot E, which is equals to rho V divided by epsilon. And we know that in the case of static field, that is curl E equals to 0, where E equals to minus del V. And this V is nothing but electric scalar potential. This V is nothing but electric scalar potential. So this is one more thing what you have to remember. We know that E equals to minus del V. So what I'll be getting is del of minus del V, which is equals to rho V divided by epsilon, or I'll be getting del square V, which is equals to minus rho V divided by epsilon. So this is Poisson's equation. So this is Poisson's equation, which is valid only in the case of homogeneous medium. Valid only in the case of homogeneous medium. Why it is homogeneous medium? Here we have considered epsilon as constant and we have taken it out and then we have solved. So based on this, the medium is an homogeneous medium. Here only I have made an assumption that it is an homogeneous medium. Say suppose if rho V equals to 0, then I'll be getting del square V, which is equals to 0. So I'll be getting del square V, which is equals to 0. This is Laplace equation. This is Laplace equation. Whenever you are getting del dot E, which is equals to 0, or if you are taking J equals to 0 as well as rho equals to 0, then it is a source free medium. Then it is a source free medium and homogeneous medium. And it is homogeneous medium. So this is very, very important. So in this video, what and all the things we have discussed? We have discussed with respect to the electrostatic field, magnetostatic and electromagnetic. In the case of electromagnetic, your electric wave as well as magnetic wave will be perpendicular to each other and then it is going to propagate. In the case of electrostatic, you will be having a radial motion, but you will not be having any rotational motion. But in the case of magnetostatic, you will be having only rotational motion, you will not be having radial motion. Electrostatic is conservative, magnetostatic is non-conservative. This is one thing what you have to remember. And 4 forms of Maxwell's equations we have discussed. And also we have discussed with respect to static Maxwell's equation and time varying Maxwell's equation. Also we have discussed with respect to Gauss law, that is del dot D, which is equals to rho V, and one more form is del dot V equals to 0. This one also we have discussed. And main thing is we have discussed with respect to Helmholtz equation, which is valid for waveguides, transmission line, antennas. How a single equation is getting modified, we have studied. Apart from this, we have studied with respect to what do you mean by divergence, curl, Stokes theorem, divergence theorem. We have studied with respect to Poisson's equation and Laplace equation also. So in the next video, we are going to discuss with respect to Poynting vector and lost tangent. So the topics based on Poynting vector and lost tangent is very, very important. If you have followed with the introductory class with respect to EMTL, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.